Okay, so here we go with our complex trinomials lesson. Weird noises in the background are my dog chewing on her bone, and it is not me. Okay, so let's try and make this somewhat short and sweet. All right, so a complex trinomial, I'll flip this up, has a number in front of the x squared that is not 1. And it is also not something that can be factored out of the trinomial, okay? These are not the first thing you want to have to see, but there are 2 ways we can do this and make it sort of simple. So what I'm going to do is I'm going to create one of those multiplication, whatever you want to call it, grids. And here's the thing. What you want to do now, the number that we want to put up here that we have to multiply to is now not just the last number. It is the last number times the first number. The first number used to be 1, so 1 times this number was always just the last number. Now, 3 times 4 is 12. We need to multiply to 12, and we still need to add to the middle number. So you need to think of 2 numbers that add to 8 and multiply to 12. And hopefully, this won't be too hard. If you need to pause and think about it for a second, go ahead. It is 6 and 2. So, from here, we have 2 ways we can go at it, okay? The first way is called decomposition, okay? And what we're going to do is basically, you're going to use these numbers, and I'm going to rewrite it, and instead of writing 8x, I'm going to break it into 2, 6x and 2x. So 8x has just been broken into 2. It's the exact same. It's still equal. I put a big equal sign there, okay? Now, if you understood the concept of factoring by grouping, you're pretty much set. That's it. That was the hardest part already. So if I'm going to do it by decomposition, I would look at the first 2 terms. What is common? What's the greatest common factor? It's a 3x. Okay, and what can we take out of the last 2 terms that is common? So these 2, we're going to group those 2 together. It's a 2. And hurrah, if you'll see here, I'll even highlight it, we have this beautiful bracket that is common. And we can pull it out as a common factor and bring it to the front. Okay, so these 2 got collected and brought here, and what's left is 3x plus 2. Okay, that was it. Not too bad. Now, if the factoring by grouping was causing you too many issues, I'm going to go and I'm going to show you one other way that I thought is actually very, very cool. All right, so I'm going to kind of try to do each of these questions more than one way. So here is what we call decomposition. Decomposition. All right. Now here's another little trick. The other thing you could do, okay, and this is important, it doesn't really make sense, but it always works, okay? You're going to do the same thing. You're going to say 3 times 4 is 12. 8 goes here. What 2 numbers multiply to 12 and add to 8? We got the 6 and the 2, so that would all be the same. Here's where the whole grid comes into being kind of cool. You take the number, what we call the A value, because it's ax squared plus bx plus c. So we take this A value and you put it underneath both of those numbers. Just stick with me, okay? Then you look at them and you decide, can you reduce them to lowest terms? Well, 2 over 3 is what it is. It is lowest terms. 6 over 3, okay, we can reduce 6 over 3 to 2 over 1. So I'm just going to bring these down, mostly because I've taken up so much room here. And here's the crazy thing. This number will be at the front of the first bracket, and this number will be at the back of the first bracket. This number will be at the front of the first bracket or second bracket, and this will be the number at the end of the second bracket. So watch this. So I'm going to use this. I'm going to say that's a 1. So 1x plus 2 is from this. Okay, so this goes here, and this goes here. And this is 3x plus 2. You got the same answer. Okay? So this one's kind of neat because you can really see what's happening. And it's something you will use later on in math. This is just cool because it's fast and it always works. Always. Tricky thing though, just make sure that the number in the bottom goes in the front. A lot of people want to go, put the 2x plus 1, but the number in the front is the one that is in the denominator. Okay, so soak that in for a second. If you need to, pause, go back, look at it, see what you think. I don't want to make this video too long, so I'm going to whip through it here. Second example we've got is 7x squared minus 23x plus 6. So if I did my little multiplication, it's going to multiply 2 and it's going to add 2. Well, 7 times 6 is 42. Negative 23 is what it has to add to. And you have to come up with two numbers that multiply to 42 and add to negative 23. Again, pause now. Take the time to think about it. I'm going to keep going to save time. It's going to be negative 21 and negative 2. Those multiply to 42 is a positive and add to a negative 23. So if I was going to go into the decomposition method, and I'll try and make it a little smaller here, I would take 7x squared, and I wouldn't write it as negative 23. I'd write minus 21x minus 2x plus 6. So these two terms came into the middle. Then I'm going to factor by grouping. Greatest common factor would be 7x. And be careful. This one, in order to end up with a negative at the end, you have to divide it a negative 2, okay? If you did not take it a negative 2, if you take it a positive 2, your signs aren't going to work. Same bracket comes to the front, and you're done, okay? Now, let's say we want to do it the other way, all right? With a little bit more room. So I, again, would do the same thing. I would come up with all these numbers, but then I would go back and I would put a 7 underneath it. Then if I can reduce, I would. So this, of course, is going to reduce to negative 3 over 1. And you have to make sure you keep the 3 over the 1, because if not, you lose your first term. And this, again, negative 2 over 7. Can't do anything. So here we go. 1x minus 3, 7x minus 2. Right? 1x minus 3, 7x minus 2. Exactly the same answer. Okay? Decomposition, I don't even know, cross method, we'll call that. All right, and I'm going to I've got 5 examples. This one, I'm actually going to try and make a little mistake here so that you can see what happens if you make a very common mistake. So, again, we've got 6x squared minus 7x minus 10. 6 and negative 10, and we've got negative 7. Again, take time. If you want to do this without watching me for now, go for it. See if you can do it yourself. I'm going to do it, and I'm going to make a bit of a mistake in this one. So two numbers that multiply to negative 60 and add to negative 7 are negative 12 and 5. So if I was to go back here, I'm going to do 6x squared. I'm going to do minus 12x plus 5x. Those two numbers right here, minus 10. And by the way, it does not matter the order you put those two numbers in there. I know it sounds crazy, but it works either way. All right? Now here's what I was going to say. I was going to say, look, what if I made a mistake and I took out, as I did, that, and then, okay, so I took out what I thought was the greatest common factor, but I don't have the same brackets. Panic. Well, the fact is that this actually still has a 2 in it. I did not take out the greatest common factor. So that's an oops, okay? Not the greatest common factor, all right? So this is a mistake. Instead, I'll move on. I hope this color works. Yeah, all right. And I'm going to go back up here and go, okay, I didn't take the greatest common factor. My dog's noisy. The greatest common factor for 6x squared and 12x is obviously 6x, not 3x. At least with x minus 2. And again, take out the 5. We're left with x minus 2. And here we go with our common x minus 2, 6x plus 5. Okay. And as a very quick, just to confirm, does it work? If we did the same thing and we went back, okay, it's a lot less work to do it this way. That's why it's so appealing, okay? It doesn't make as much sense, I don't think, but so can't reduce that. What does negative 12 over 6 would reduce to negative 2 over 1? So our bracket would be x minus 2 and 6x plus 5, okay? Notice I always put the negative in the numerator because you want it to show up in the middle. You don't want to have a negative in front of your first term. Okay, I got 2 more examples to do. This one I put in here just because I want you to see what happens if you have an extra variable, all right? So, if we go to this one, we're going to do our cross. We've got 8 times 1, so totally ignoring the variables in this one. So we have to have 2 numbers that multiply to 8 and add to negative 9. Okay, to me that is kind of easy to do. It's going to be negative 8 and negative 1. So if we go to our decomposition, and again, if you want to skip the if you've chosen which way you want to do it by now, you just go ahead and do it whichever way you want. So I broke this into negative 8 and negative 1. Okay, take out a common factor of 8x, and we get x minus y. And again, be very careful because we got to end up with a negative in our bracket. So this sign has to change. So we're going to divide out a negative y to leave us with an x minus y. X minus y, Mabel, you're loud. And x minus y, 8x minus y. Okay? And once again, if we were to be quicker, we would do this same thing, go back, divide by 8 on both sides. It's always divide by a, always. This reduces to negative 1 over 1. This stays negative 1 over 8. And so I get x minus, now this is where you got to be careful. Remember, it's not just 1, it's a y. We have that variable in there, okay? So this is a little tricky in that you don't have your variables in it. This keeps your variables. This one you have to remember to go back and put the variables in there. And then that's 8x minus y, right? 1x minus 1y, 8x minus 1y. All right, very last one. Whoo, my arm's getting tired doing this one because in this case, this is a big thing you have to remember. We're not going to tell you right now. Right now, what we would say is we would give you a hint by saying factor completely. If you see that, that is a big warning bell. I wonder if I can draw a bell. There we go. Yeah. Ding dong. That you have to take out a common factor. All right? So the first step to this one, and I love the fact that I can do all this in colors, you have to look for a common factor, and in this case, it is 3x squared plus 5x minus 2. All right, once again, we haven't got x squared by itself, so we have to deal with this. So this 3 that we took out as a common factor, we're going to do exactly what we've been doing the whole time. The 3 is just going to follow along, okay? So over here, 3 times negative 2 is negative 6. It has to add to 5. The 6 and 5 conundrum. So what multiplies to negative 6 and adds to positive 5? It's not 2 and 3. It's going to be positive 6 take away 1. All right? So if I'm being really lazy about this, I could easily just go Remember, this is out here. We don't even think about this anymore. So now our value of A is 3, all right? Don't go and put 9 in front of it. I can see that being something people would do. Reduce to 2 over 1. Reduce, well, you can't. So the answer is going to be x plus 2 and 3x minus 1. And that common factor of 3 is going to get thrown in the front. Okay, I did it the lazy way first. I will now take the time to go and do it by decomposition. So it was plus 6x minus 1x minus 2, which is 3. And I'm going to have a double bracket coming in here in a second. I'm going to take a 3x out. We're going to have x plus 2. We're going to take out a negative 1. X plus 2. So that's kind of manipulation. Like there's not really a common factor in there. We don't think of 1 as a common factor, but we're going to change this. We're going to take out the negative 1 so that our brackets match. So we've got these brackets inside brackets, which is a little bit confusing. Okay, and there you go. All right, hope you enjoyed this. We'll go over and do a really quick navel pose.
Yes, you're gorgeous. Thanks for helping.
All right, and I'll post some questions later. Bye-bye.